Let's begin. Today is May 9th, 2024, and we're ready for the Daily Turing Machine Puzzle. Notice that we've already assembled our 6 criteria cards and our 6 verification cards. Remember, you can always go to turingmachine.info and generate the daily puzzle. Here again are our 6 criteria cards, and we're using the yellow or orange classification verification color. Let's look at our puzzle. So remember, we have our 6 criteria cards. Top row are criteria B, C, and the second row contains criterion card D, E, and F. Let's look at criteria A. Criteria A will let us know a little bit about the first digit, represented by the triangle, and it's comparing it to the digit 3. So is our triangle digit less than 3, equal to 3, or greater than 3? Criteria B will tell us a little bit about the square digit and whether it is an even or an odd. Criteria C compares the second and third digit, the square and the circle, and we're trying to determine if the square is less than the circle, are they equal to each other, or is square greater than the circle. Criteria D will let us know a little bit about all 3 digits together and whether there are more even than odds or more less even than odds. Criteria E uses the triangle and the square, the first 2 digits, and it's comparing the sum to a total of 6. Is the sum less than 6? Is it equal to 6? Or is it greater than 6? And lastly, criteria F tells us a little bit about all the 3 digits, and we're going to determine whether all 3 digits are unique, meaning there's no repetition, as in example 125. Could the 3-digit code that we're looking for have a pair of digits, represented by an example of 112? Or is it possible that all 3 digits could be the same one, as in the example 222? Okay. Remember, the objective of the puzzle is to find a unique 3-digit code that meets each of the following conditions. Okay. Well, let's begin. I've already set our first proposal to the digit 314, and what I'm going to do is I'm going to test B. I want to see if the middle digit is even or odd. Okay, so the Turing machine says it's incorrect. My proposal of 1 is incorrect, which means that it is not an odd, therefore it's an even. So I'm going to come to my notes, and I'm going to state that the square digit is even. Is even. And so since it is even, and of course odd failed, I'm going to cross out all of the odds. So slowly we'll be getting closer to our desired 3-digit solution. All right, so we know that the square is even, and well, we do have a criteria that tells us a little bit about the number of evens versus odds. So let's actually test criteria D. Okay, so it came back false. So notice that in my proposal, I do have 2 odds versus a 1 even. The Turing machine is basically telling me, no, that's not correct. So if there should not be more odds than evens, well, it's the opposite. So there should be more evens than odds, and that is criteria D. So in my D notes, I'm going to say that even is greater than odd, and what that basically means is that there are either 2 evens or 3 evens. Okay, so if there are more evens, at a minimum there should be 2, versus potentially they could all be. Okay, and to maybe help us out as a third Turing test, let me test criteria F, since it's telling me that there Could there be a repetition? Could there be a pair? Could there be no repetition? Is there a pair, or potentially all the same? So let's test F. Okay, so they say the Turing machine replies, yes, it's correct. Look at my proposal. All 3 digits are distinct. So that means that the Turing machine approved that. And so that means that there are no repetitions. So in my notes for F, I'm going to state that all digits are unique. All digits are unique. Okay? So at this point, we've already tested our 3 allowed Turing tests per turn or per proposal. So I have to now generate a new proposal for the next round. So again, we do know that they have to be distinct. So, and they're more evens. So actually, let me update my notes here and state, since they are distinct and there's more evens, actually that really means that I have the digits 2 and 4. So use 2, 4, and 1 odd, and an odd. Okay, so again, so the logic is, the deduction is that if we do have more evens than odds and they're distinct, that means I can't have 2 of the same even, right? If I have 2, 2, that would not be distinct. So that means that it would have to be 2 and 4. And because I can't duplicate, I can't have a copy of either a 2 or a 4, that means that that 3rd digit must be odd. So that means that my code will contain 2, 4, and an additional odd. So I got to use that information in order to kind of generate my new proposal. Okay, and at this point, I really can't eliminate, any of the 1s, 3s, or 5s that haven't been already eliminated, because I just don't know which one it could be. So let's look at what I haven't done. I haven't done criteria A, which is the first digit, the triangle, and it's comparing it to 3. Potentially that could be my odd, right? There is a triangle equals 3. That could be it. Let's take a look at C. Here we're comparing square and circle. Now notice, since we do know that they're all distinct, we know that square and circle cannot be equal. Right off the bat, we can eliminate that by deduction, that we cannot have square and circle be equal. So one's either greater or the other. Okay, so we'll have to keep that in mind. And then obviously criteria E, where we're summing the first 2 digits and comparing to 6. Okay, so obviously A and E are somewhat related, since they both have the triangle digit, and then we're comparing square and circle. So at this point, let's see, if triangle were the odd, and let's just say it may be 3, then perhaps if I'm constrained to get the square, that means that circle would be the other even, potentially. Could that be it? And we also know that square and circle are being compared. So if that were the case, if it's 3, yeah, I don't think it could be 3, because if it were 3 and it tells us, oh, the sum is, say, less than 6, so I choose 2, or it's greater than 6, it'd be 7. I think it'd be obvious that which one would be greater, right? If it's 2, I would already know that 4 is greater, or vice versa. If it's 4, I would know that 2 is less. So that kind of leads me to believe that perhaps it's not going to be a 3. So somehow, what else can we do to constrain our sum here? So I believe that maybe then this will be even, And perhaps it forces, well, this is even as well. So that means if I choose even here and even here, this is an odd. Is that a possibility? So if that were the case, if these two were even, that would be a total of 6. And then based on the order of them, that would lead me to believe what odd would go for circle. Is that plausible? If it were 4, then I would almost have to choose 5. If it were 2, then I'd almost want to choose 1. So I think that's what I'm going to do. I'm going to propose it's 2, 4, 5. 2, 4, 5. Let's see. If I choose that to be 5, and it's bigger, 2. Yeah, let's give it a try. We have to do something. So 2, 4, 5. Okay. So let's choose, the sum. So let's test criteria E. Okay, so I was incorrect. It's not 6. So for criteria, E, criteria E is the sum, and so we know then that the sum of triangle and square must be either the sum of triangle and square must be either bigger than 6 or less than 6. So it's either, we'll say less than 6 or greater than 6. Okay, since it's not equal. Okay, and then let's test criteria A, and we're going to compare our triangle. So that's criteria A. Okay, so that is correct. So we do know that triangle is less than 3. Okay, so going back to E, I didn't think to see if I can eliminate any choices, but for criteria A, since it is less than 3 and it is correct, that means I should be able to eliminate obviously the digit 3, the digit 4, and the digit 5, since those are all not less than 3, only 1 and 2. Okay, and since we are talking about, let's go back to the sum property. If I only have, notice the following. If I have it, basically reduce my options for triangle to be 1 and 2, and I'm adding it to square, notice that 2 plus 4 is 6, and we know it's not 6. So that means that we can actually eliminate the number 4, because 4, well, let's see, hold on. No, I guess technically it could be 1 plus 4, or actually, let's see. If I eliminate 4, no, it could be 1, 4. That would still be valid. I can't eliminate 4. But I think what I'm trying to get at is that it must be, I think we can deduce that the sum should be less than 6, because if I do use 4, obviously it couldn't be 2, it would have to be 1. There's no way to be able to get a sum greater than 6 just using the 1 and 2. So that means I am going to cross out this or. So it can't be greater than 6, it's got to be less than 6. So again, the reason is 4 plus 2 gives us 6, which we know is invalid. So that means that 1 plus 4 could be it. And then, of course, I still would have 1 and 2 and this 2. So yeah, so we know that it's going to be less than 6. And 4 is still an option. But we already know it's less than 6. And what else? Anything else so far? So that really hasn't told us anything about purple. Because I could have the odd here. All right, so we are able to compare in criteria C. So let's test C. That may help us out. Okay, so that is also correct. So for criteria C, we're comparing square and circle, and notice that in my proposal, I have 4 being less than 5. So that is correct. It is true that square should be less than circle. So let's do that. So square should be less than circle. So again, the way we read that, it's not that it's definitely a 4 or 5. All we know is that square should be less than circle. So since square at a minimum is a 2, then we should be able to eliminate the 1 and of course 2 itself. So that would leave us with 3, 4, and 5 for circle, since 3 is greater than 2, 4 is greater than 2, and 5 is greater than 4. So I can't eliminate any of those choices. And so let's see. Remember that we're dealing with all unique digits. So what can do we have enough information to come up with a final proposal? Well, let's actually do this. I'm going to list out all the potential solutions and see if there's anything that kind of jumps out. So we could have triangle 1 and then 2, and then for the rest it could be either of them. It could be a 3, it could be 1, 2, 4, it could be 1, 2, and 5. So again, I just chose 1 here to add to 2, that's less than 6, and then it could be 3, 4, 5. Okay. If it's 1, it could be a 4. So it could be 1, 4. Remember, it's got to be unique. So either 3 or 1, 4, 5. So again, I already did the 1, 2s. And so now 1, 4. And then 3. I skipped 4, 4 since I can't have a duplicate. 4 and then 5. And so that does it for 1. 1 already used both of these cases. So I move on to 2. So that means that the only possibility for the first 2 digits would be 2 and 4, and then 3, and then 2, 4, and 5. So those are all the possibilities. So as a reminder, I think I can eliminate 1, 2, 3 since I need 2 evens. So I can eliminate that as a possibility. I do have 2 evens here. I can eliminate 1, 2, 5 for the same reason. I need 2 evens. I only have 1 there. Same thing for 1, 4, 3. I can eliminate that because there's only 1 even. And same thing for 1, 4, 5. Maybe I should have considered that before. And 2, 4, 2, 4, and 2, 4. Okay, so let's go back. So I've narrowed it down to only 3 possibilities. And more than likely, there's something about 2 of these that are, ambiguous or redundant. Oh, I just noticed 2, 4, 3. It would violate my square being less than circle. The middle one needs to be smaller. So this is incorrect. And okay, so that leaves us with these 2, 1, 2, 4. Triangle, both of them are less than 3. The middle digit is even. The square is smaller. The middle number is smaller than the third number. That's also true. Both of them have an even. And 2, 4, 5 is equal to 6, which we concluded earlier, or the Turing machine replied that no. So it looks like we're down to just that one possibility. So let's actually verify here. I'm just going to write down 1, 2, 4. And I'm going to come back over here and verify that everything is met. So is triangle less than 3? Yes, the first digit is less than 3. Is my middle digit even? It is. Is the middle digit less than the third digit? That's true. True is less than 4. Do I have more than 2, or do I have 2 and 4 and an odd? Yep, I have 2 and 4 and 1 odd. Is the sum of the first 2 digits less than 6? Yes. 1 plus 2 is 3. That's less than 6. And are they all unique? Okay, so based on our deductions and what the Turing machine has told us, I feel confident that 1, 2, 4 is our solution. So let's go back to turingmachine.info website, and we're going to plug in our code of 1, 2, 4. And let's see. Fantastic. That is actually correct. Okay, now here's the real test of our deduction. How did we do compared to the Turing machine? So let's actually go back to our puzzle site and see how we responded. So in the first turn, we used criteria B, D, and F. So B, D, and F. B, D, and F was correct. And for our second turn, we used the other 3, and it was A, C, E, and the first 2 are correct. So A, C, E, and the last one was, I believe, incorrect. Let me just double check. Yes. Okay. And so let's see how we compared. Wow, look at that. We did it in 2 rounds, 6 questions, while the Turing machine did it in 3 rounds and 8 questions. Well, that's a great win. Well, that does it for today. Remember, if you like this video, please give it a thumbs up. And if you don't want to miss tomorrow's puzzle, subscribe to be notified. Well, that's it for today. Have a great one.